I welcome all my students to the video class of functions. We are facing an unprecedented event in the history of this decade. In fact, I should be speaking the history of this century, the 21st century, and that is why we have to innovate methods of learning. See, this video is a supplementary study system. Supplementary means it should be followed by the assignments which I'll be providing and the discussions which you will be seeing in this video. So, since the 12th part consists majority of the calculus, so it is highly necessary that you have a very good idea of the chapter functions. The chapter functions serves as a foundation stone for all students of class 12. You need to be very good in functions in order to have a sound understanding of entire calculus. So let's get started. Now the first thing what I want you to know is what is a function. Now many of you might have learned something from here and there, that is stits and bits, but now let's get into the fine details of this. Now first you need to know what is a relation. Now if I say that A and B are two non-empty sets, say A is this much and B is say 1, 2, 3. Now अगर हम इसका कार्टेशियन प्रोडक्ट लेते हैं तो ये क्या देता है x1, x2, x3, y1, y2, y3 and similarly z1, z2, z3. Cartesian product of any two sets can be written like this and you can easily find out. Now any subset of this is called a relation. So one point here that I'd like to specify is, if the cardinal number of set A is equal to suppose m and the cardinal number of set B is equal to n. So in that case A cross B will consist of m into n elements. Now how many subsets can be possibly formed out of this given set? See, we can form 2 to the power 9 subsets. As far as subsets is concerned, I'd like to remind you that there are only 2 options for each element. Either it is included in the subset or not. Now, so there are 2 options for each of them. So for 9 of them, how many options are there? 2 into 2 into 2, 9 times. That makes it 2 to the power 9. So if the Cartesian product of two sets A cross B consists of m into n elements, so the number of relations that can be defined is 2 to the power m into n. So this is an important data which you should remember. So if the cardinal number of set A is m, cardinal number of set B is n, so a maximum of 2 to the power mn relations can be defined out of it. So now let's proceed further. Now if I take a couple of subsets, suppose I am taking the first subset, say R1, as x1, y2 and z3. So how does this look like in mapping? See, if I form a mapping, see, if this is my set A and this is my set B. Now x is mapped with 1, y is mapped with 2 and z is mapped with 3. So this is in mapping diagram, this is how we can represent the first relation. Now as you can see, x is mapped with 1, y is mapped with 2 and z is mapped with 3. So this kind of a relation, I'll say, kind of a mapping, I'll say it is a 1-1 mapping. Now the left side of this is called the domain of the relation and the right side is called range of the relation. Now if I take another example, suppose I am writing x1, x2, x3. See, this is also another relation. So how do I represent it in mapping? See, x, you have only one element here, 1, 2, 3. So x is mapped with 1, x is mapped with 2, x is mapped with 3. So you have this kind of mapping. Now this will be called a one-many mapping. Now let's take few more examples. So in this case the domain is x and the range of the relation is 1, 2, 3. So now if I draw another mapping, now suppose I am writing say R3. Now if I take x1, y1 and z2. So what do you get here? You have x, y and z as the elements on the left hand side and 1 and 2 on the right hand side. See, x is mapped with 1, y is mapped with 1 and z is mapped with 2. So I'll say this kind of relation, now this kind of mapping, sorry, this is a many-one map. So as you have seen, there are practically speaking three kinds of mappings possible: 1-1, 1-many and many-one. Out of them, 1-1 and many-one relations can be called functions. 1-many relations can never be called functions. So now let us analyze this properly. As I told you, which kind of relations? 1-1 mappings and many-one mappings. So many-one mappings, now they are called functions. So function is basically what? It is a kind of relation between two set of variables, one on the left, one on the right, such that the kind of mapping that exists between the two is 1-1 or many-one. Now let us understand it in details. So if I say that x is a set and y is another set, both of them are non-empty sets of real numbers. So if I have a mapping like this, such that every element present in set x is uniquely associated with an element of y. Every element of set x has a unique image in set y. So then the relation that is obtained will be called a function. Now let me break it down into two parts. In simple language, I can say every input that is being provided in x, that gives an output, and there is no such input which gives more than one output. Now this should not happen. यानी हर इनपुट एक आउटपुट देना चाहिए, कोई ऐसा इनपुट नहीं हो जो आउटपुट नहीं दे. अगर ऐसा होता है तो हम कहेंगे ये फंक्शन है. प्रैक्टिकल टर्म्स की बात करें तो मैंने इनफाइनाइट रिलेशंस में से एक रिलेशन पिकअप किया y इक्वल टू x. अगर मैंने x को 1 पुट किया, y कितना आता है 1. x को 2 पुट किया, y कितना आता है 2. x को -3 पुट किया, y कितना आता है -3. Every value that I am providing as input is giving me an output. Does it ever happen that for a particular value of x, you get more than one value of y? No. So I will definitely say that y equal to x is a function. So this particular relation between x and y can also be called a function. Now here I'd like to point out one thing, that all functions are relations, but all relations are not functions. Now, I'd like you, all of you, to note down the basic definition of a function. If x and y are two non-empty sets of real numbers, then a relation from x to y can be called a function if and only if each and every element of set x has a unique image in set y. Now, this is a manual method of identifying functions. Now, let us approach this geometrically. Now, if I draw the line, the graph of y equal to x, see, this is the kind of graph that it forms. Now, if I draw a line parallel to y-axis, see, it intersects this graph only at one point. Now, what is the meaning? Any line parallel to y-axis signifies x equal to constant. Now, x equal to constant. Now, for this value, say c1, you get this value c2. For this value, you get this value c1, sorry. For c2, you are getting y to be c2. That means for every input, you are getting only one output. So, looking at the graph itself, I will say this is a function. Whereas if I consider the graph of y square equal to x. Now, if I draw a line parallel to x-axis, it always cuts the graph at more than one point. So, it means that corresponding to this value of x, we get two different values of y. Now, if we are getting two different values of y, so the output is not unique. The output is not unique, so I cannot say that this is a function. Whereas if I take the example of y equal to sin x, see, the graph of sin x, it forms something like this. Now, if I draw a line parallel to y-axis, it always intersects the graph at one point. So what does it mean? It means that corresponding to each input, the output is unique. So this is the simple graphical test of whether a relation represents a function or not. If a straight line drawn parallel to y-axis, it intersects a graph at one point, then the graph definitely represents a function. But if it cuts the graph at more than one point, like in this case y square equal to x, or I can take the example of a circle, see, it cuts the graph at more than one point, or you can have any such relation, say, suppose it represents like this. So this is also not a function, this is not a function, this is not a function. So it will be an ordinary relation, but it will never be called a function. Now, after identifying which one represents a function, let's move on to the understanding of the terms codomain, domain, and range of a function. Now, in every function, three different entities are involved. In every function, three different entities are involved. You have a set x on the left hand side, you have a set y on the right side, and in between they are linked with a particular procedure. Now this procedure, see, this I can say this is your input, this is your output, and this you get the output corresponding to an input being provided. Say for example, if I have written a relation y equal to x cubed. So x is my primary variable, that is my independent variable. Y is the dependent variable. And taking cube is the procedure. Now, corresponding to the input being provided, If I say provide x equal to 1 as the input, I get y equal to 1 cube as 1. If I put x equal to 2, I get 2 cube, that is 8. So that means you are applying a procedure here. Now my question is, how do I understand which one should come into existence first? See the set y. Now set y is technically called codomain of a function. Now this is the set which comes into existence first. If, or you can also call this particular set the set of desired output. Set of desired output. We can also call this set. See, understanding this, which one should come first, is pretty easy. Say for example, if we take the example of a fan present in our house. Now, the first thing that comes to my mind, in fact, it should come to everybody's mind, is why has a fan been created? Because we needed a machine which recirculates the air present. For create, that was the need. So the need comes in mind first. Now, corresponding to the need, now it was thought कि okay, पंखा घूमेगा कैसे? ऐसा एक मशीन तो बनाया जाए, लेकिन ये घूमेगा कैसे? तो पहले पुराने जमाने में हाथों से घुमाया जाता था, लेकिन उसके बाद एक प्रोसीजर डिफाइन किया कि let us place a coil inside a magnetic field. तो ये एक प्रोसीजर हो गया कि मैंने एक कॉइल प्लेस कर दिया मैग्नेटिक फील्ड में, एंड व्हेन द इनपुट इज प्रोवाइडेड एज करंट, द फैन रोटेट्स. So it's very simple to understand that the codomain of the function, the set y, it comes into existence first. Corresponding to the output you want, you decide a procedure. And lastly, the set of input is defined. Now, understanding this, so there are two options. The set y, which is codomain of your function. Now, either you have an option of specifying what you want, or the second option is by default it will have a value. So I am talking of the first option. See, if I write like this, fx to y, where fx is equal to something, that means some procedure. So this is the language in which I am specifying, okay, I want this set as my output, and the set which we will be providing as input to get the elements of my codomain as output corresponding to this procedure. So this restricted set will be called domain of the function. Now let us take a very simple example. If I write fx to n, where fx is equal to, say, log x with respect to base 10. Now, no doubt I have specified the set y to be 1, 2, 3 up to how far? N. That means I want the set of all natural numbers as output. And the procedure that I have chosen for this is y equal to log x with respect to base 10. Now tell me, how do you get 1 as output? For getting 1 as output, I need to provide 10 as input. For getting 2 as output, you need 10 square as input. For getting 3, you need 10 cube. And for getting n, you need 10 to the power. Now, can you provide any number, any other number as input in this set? If I provide 1 as input, log 1 is 0. 0 is not an element present in set y. 0 मुझे output नहीं चाहिए. तो क्या हम 1 यहाँ पे डाल सकते हैं? No. That means the set of restricted values which x can have to get the elements of y as output, this restricted set is called domain of the function. Now, ये पहला ऑप्शन है कि मैंने स्पेसिफाई कर दिया कि मुझे ये चाहिए. अगर मैंने ऐसे स्पेसिफाई नहीं किया, मैंने सिर्फ एक प्रोसीड्यूर स्पेसिफाई की, तो यहां कोडोमेन का डिफॉल्ट वैल्यू होता है the set of all real numbers. Say for example, अगर मैंने लिखा सिर्फ y equal to root x, see I have written positive square root of x, so that means अगर हम 4 का स्क्वायर रूट लिखेंगे तो सिर्फ 2 लिखेंगे, नॉट प्लस माइनस। तो यहां पे कोडोमेन क्या हो गया, द सेट ऑफ ऑल रियल नंबर्स। So this is my set y, that is minus infinity to infinity, all the real numbers. अब ये सेट मुझे आउटपुट कैसे मिलेगा? Procedure I am adopting is y equal to root x. तो अगर मैंने y equal to root x लेना है, square root of which quantities can give me something which is real? Can I take a negative quantity? No. Square root of negative quantity will give you an imaginary quantity. So negative quantities cannot be provided as input here. What you need to provide as input is 0 to infinity. So now look here. In this case, y equal to fx. My only concern is the values of x that I should provide as input for y to be real and defined. So in this case, the domain should be focused on that aspect, that we should focus on just y being real and defined. Now, this entire set is my codomain. Now, if I put x equal to 0 here in this, I get 0. If I put 1 here, I'll get 1 as output. If I put 2 here, I'll get root 2 as output. And like this, we will go on getting all the numbers. Now, the question is, how I am getting these elements? I am getting these elements by putting these values in the functional equation. So these elements will be called functional images. So the input we are providing, that is domain, and the output which we are getting, they are called functional images. Now, these elements which are present in the left side set, they are called pre-images. So, all the elements of your domain are pre-images, and the elements which we get as output corresponding to the input being provided, now these are called functional images. Now, if I collect all the functional images, now this set will be called the range of the function. So the practical difference between codomain and range, what is it? Codomain is the set which we want as output, whereas range is the set which we practically get as output, corresponding to the input being provided. So if I write a function of the form y equal to sin x, now, for this, no doubt the codomain that we will take into consideration is R. Now, does sin x give you an output outside the interval minus 1 to 1? Sin x का कभी भी value minus 1 से 1 के बाहर आता है? नहीं आता है। इसका मतलब ये हमेशा minus 1 से 1 के अंदर values देगा। तो इसका range क्या कहलाएगा? The range of this function is minus 1 to 1. So, this is the set which we want as output, and this is the set which we practically get as input. Now, let us understand the geometrical interpretation of domain, codomain, as well as range. Now, how do we draw a graph of any function? We draw the graph of any function by plotting the x coordinates and y coordinates. So if I have drawn a graph, suppose this is a graph y equal to f of x. This is x-axis and this is your y-axis. Now, which points we can see on the graph? We can see only those points which have real x and real y. So real x coordinates and real y coordinates will make up this. Now, if I want to collect all the x coordinates occurring on this graph, I have a very simple option. Let's take the projection of this over this entire x-axis. That means the shadow of this graph over x-axis, it comprises of A to B. So the projection of any graph over x-axis will give you nothing but domain of the function. In practical terms, if I take, say, fx equal to log x. Now, if I want to find the domain of this function, if I project this graph over x-axis, it will cover just the positive part of x-axis, because this part is never going to touch practically. So the right side, that means r plus, this is the domain of your function. So projection of any graph over x-axis signifies domain of a function. If I project this graph over y-axis, it covers this part. So this part, represents C to D, it will represent the range of the function. So projection of any graph over y-axis gives the range of the function. Now, I haven't specified any set x and y here. So by default, the whole y-axis signifies the codomain of the function. So once again, I'll repeat. Projection of any graph over x-axis signifies domain of a function. Projection of any graph over y-axis signifies range of the function. And if no set x and y is given, the entire y-axis represents its codomain. Now let us take one more example. If I am writing, say, f r 2 minus 2